let's begin with question number 5 on this paper. Okay, as we read, we'll move it to a whiteboard, please. Okay, the function f is defined by fx like that, blah, 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 and where a and b are constants. So it is given that f2 is 1 and f5 is 7. So that's how we read this. And then let's find the values of a and b plus. So the first step in such a question is to recognize that fx equals to ax plus b is the equation way of writing the same thing. Yeah? These two are equal. So I just want to mention that first. So that means whether you write the function in the mapping style like this, f is mapping x to ax plus b. That's how we read this. Same as saying fx equals to ax plus b. Okay, so these two things are equivalent. Okay. Okay, now we need to substitute the values of given values, that means 2 and 1 like that, meaning that, okay, let me write below it like that, thinking how to, like, make it a bit more, like the details, sometimes for some details could be important. So like that. That means what I'm trying to say is that's how they know that the x is 2, same as putting x equal to 2. And then the whole thing on the right-hand side is the ax plus b from here to here, because the equal sign separates that, is equals to 1. But here, the ax plus b, the x part is actually substituted as the 2. So this is how it comes to play. X equals to 2 here, or even from here, all the same. So x equals to 2. So this is why we write it as 2a plus b equals to 1. Okay, let's make it the b is the subject of the matter because there's a coefficient of 1. Okay, all right, let's take this as equation 1 plus, and then we can do the second equation. Beside it, with the substitution likewise using f5 now equal to 7. So f5 equals to 7 means, below it, we're going to match it up. So if I just copy it, just to learn this in detail, ax plus b like that, I see. So in the similar style, you can see that x equals to 5 is the substitution that is matching here. And then from here to here, we match it up with the 7. So ax plus b is 7, from which case we just substitute further this part as 2. So sorry, x is 5. Read the earlier one. So x is 5 here. Please take note. And then this becomes 5a plus b equals to 7. So this would be the second equation. So two unknowns, we can easily solve for the value of a and b. And that's what we're going to do now. So to solve, so you can just write like a word solve like that. Then you can say substitute or put equation 1 in 2. Ta-da! That means it becomes 5a plus the b is 1 minus 2a. The b is 1 minus 2a. And then the whole thing equals to 7. 5a plus b. So you must read it like this b is being substituted out. So instead of writing letter b, we are writing 1 minus 2a. That's what substitution means at this step. So the three arrows there, if you look at this arrow and then you go down and look at this arrow and then you look at that arrow, you should be able to connect the three things and understand this statement. So now we've solved it further. So I'm just going to do it here. So 5 minus 2a, 3a plus 1 is 7. So 3a equals to 7 minus 1 is 6. So they're simplifying things. A over 3, or in other words, the value of a is 2. So a is 2 means we put back. I always need to put back in which one, which equation. We need to put back in, let's say, in equation 1, because we need to calculate the value of b. So b is 1 minus 2a. So 1 minus 2, the a is 2. Ta-da! 1 minus 2 times 2. Or in other words, is negative 3. 1 minus 4 is negative 3. So there we have it, the a and b. And finally, we can write the answer. Ta-da-da. Oh, the only one there are a and b. So a equals to 2 and b equals to negative 3. Okay, for the second part, we can do it in the same screen here, I guess. Okay, so what we need to do is just copy this across first. So fx was given as ax plus b. So we just substitute these numbers first. Aha. So it becomes 2x minus 3. The a is 2, b is negative 3. So they want you to solve the equation. They want us to solve the equation f of x equals to 0. So one of the ways to do this, there are two ways. So one, they substitute the fx itself. So fx itself is 2x minus 3. Ta-da! Something like this. Okay, in the 2x minus 3 now, this is like f, then the input is 2x minus 3. So we just change the x part. The equal to 0 is because we copy it from here. That means I'm just reading it off from this part. Ta-da! So 2 bracket, the x is just a bracket. That means it becomes like a structure. 2 structure minus 3. Think of it like that. Easier to understand the functional substitution here. So the functional substitution means, like instead of putting an x here, now you put 2x minus 3 means here 2x minus 3. So that means the 3 orange arrows tell me that this is 2x minus 3. Oh, so that's how they read this functional notation. Now let's expand this out and solve it. So this times this times this. It means 2 times 2x is 4x. 2 times minus 3 minus 6 minus 3, 0. So solving which we get this is 9. Oh, x is 9 over 4. Instead of writing 9 over 4, if the decimal ends, it's good to write, which is 2.25. Okay, so x is 2.25. Thank you.